Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on October 3rd, 2025, about 5 days ago. The big hook is that this paper introduces the first non-autoregressive multimodal model that generates text and images concurrently and interleaves them freely, while using up to 50% fewer training floating point operations than autoregressive baselines. The paper is titled OneFlow, Concurrent Mixed-Modal and Interleaved Generation with Edit Flows. And as we will see later, the implications for model training are quite significant. Beyond the headline, it unifies insertion-based edit flows with flow matching, scales efficiently, and reports stronger generation and understanding with natural reasoning like sampling. The introduction just set the stakes for concurrent generation. Figure 1 shows the process in action, with blue prompt tokens, yellow generated tokens, and image squares that start as noise and then resolve. The sequence grows by insertions, so the model adds words and image slots where needed rather than predicting strictly left to right. Text and images refine together, which prioritizes content first and lets grammar and visual details settle as confidence rises. Well, Figure 1 showed how the sequence grows by insertions. Figure 2 shows text-to-image generation at 512 by 512 resolution, presenting a grid of diverse scenes and styles. The results cover fantasy landscapes, cute characters, food, animals, robots, and architecture, which signals strong prompt alignment and stylistic control. The compositions look coherent and detailed, so the method maintains global structure while preserving fine textures. Okay, Figure 2 showed single prompt to image results. Figure 4 presents concurrent interleaved generation, where the model writes a paragraph and inserts image slots that are denoised alongside the text, so both modalities inform each other. The gradient bar from t equals 0 to t equals 1 indicates when tokens were finalized, which highlights a content first, detail later progression. The two flower photos on the right were inserted mid-paragraph and refined while the descriptions evolved. Alright, Figure 4 presented concurrent interleaved generation. Figure 5 shows scaling plots versus floating point operations, comparing AR and FM to OneFlow across 4 metrics. At the same compute, OneFlow reaches higher DPG scores, lower FID, and stronger caption quality on CID-ER and Rouge-L, which signals better scaling. The dash trend lines rise or fall more steeply for OneFlow, so comparable quality arrives with much less training compute. So Figure 5 showed steeper scaling for OneFlow. Table 1 reports parity floating point ratios, which indicate the fraction of OneFlow compute needed to match the autoregressive plus flow matching baseline. The numbers read about 0.5 for DPG, 0.97 for FID, 0.32 for CID-ER, and 0.42 for Rouge. Lower values mean savings, so prompt alignment and captioning achieve the biggest compute reductions. So, Table 1 highlighted compute savings. Table 2 compares image generation and captioning after multimodal pre-training. It shows controlled comparisons plus prior systems, with OneFlow and OneFlow Mixed achieving the strongest overall balance. The models reach lower FID around 10 and higher DPG near 80, while Mixed training lifts caption scores to about 142 CID-ER and 61 Rouge, which signals consistent gains without trading off image quality. The shaded cells mark the best results. Well, Table 2 compared pre-training outcomes. Figure 19 shows the architecture, with a single bidirectional transformer that handles both text and images at once. Text enters as embeddings and produces insertion logits and insertion rates, which drive the edit flow token insertions. Images pass through a generation encoder and downsampler, start as noise, and use a flow matching velocity head with an UP sampler to denoise. The two branches stay synchronized, so interleaved tokens and images co-evolve during generation. The key takeaway is a single non-autoregressive backbone that inserts text and image slots concurrently, using edit flows plus flow matching to prioritize content first while saving up to 50% training compute. The broader implication is smoother, interactive, multimodal systems that reason while generating. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.